Imagine waking up to a sky that no longer looks familiar. The stars are still there, but something feels wrong. A faint darkness has appeared where nothing should exist. It isn't a cloud. It isn't a planet. It isn't even visible in the ordinary sense. Yet astronomers across the globe are watching in stunned silence as entire regions of space begin to bend around an invisible giant. At first, no one believes the impossible. Then, measurements arrive. The object approaching our cosmic neighborhood has a mass so enormous that it defies imagination. It outweighs tens of billions of suns. Light itself struggles to escape its grip. Entire galaxies have spent billions of years orbiting around monsters like this. Somehow, one of them coming toward us. What would happen if the biggest known black hole in the universe drifted dangerously close to Earth? Would planet be whole? Would the solar system simply disappear? Or would something even stranger happen long before the black hole ever reached us? The answers are far more terrifying and far more fascinating than most people realize. To understand this nightmare, we first need to understand what a black hole truly is. Popular culture often portrays black holes as giant cosmic vacuum cleaners that roam the universe, endlessly sucking in everything nearby. It is an image that makes for exciting movies, but reality is both more subtle and infinitely more extraordinary. A black hole is not a hole in space. It is a place where matter has been compressed so intensely that gravity overwhelms every other force in nature. Space and time themselves become distorted. Instead of objects simply falling toward the black hole, the very fabric of the universe bends around it. Imagine placing a bowling ball on a stretched rubber sheet. The surface sinks beneath its weight, causing nearby marbles to roll inward. Now replace that bowling ball with an object billions of times heavier than our Sunday, and replace the rubber sheet with the structure of space-time itself. That begins to hint at the true nature of a black hole. Most black holes form when massive stars reach the end of their lives. After exhausting their nuclear fuel, they collapse under their own gravity, leaving behind incredibly dense remnants. These stellar black holes typically contain anywhere from a few to several dozen solar masses. But those are only members of the black hole family. At the centers of most galaxies, including our own Milky Way, lie supermassive black holes. Sagittarius A, the one at the center of our galaxy, contains about 4 million times the mass of the Sun. Despite its unimaginable power, Earth remains perfectly safe because it is roughly 26,000 light-years away. Its gravity governs the inner structure of the Milky Way, without threatening distant planetary systems like ours. Yet even Sagittarius A is tiny compared with the true giants of the universe. Astronomers have discovered black holes so massive that they challenge our understanding of cosmic evolution. Some contain billions of solar masses. These titanic objects sit at the hearts of enormous galaxies, feeding on surrounding gas while shaping the growth of entire galactic clusters. Among the largest known is TON 628, an ultramassive black hole estimated to contain tens of billions of times the mass of our Sun. Its event horizon, the boundary beyond which nothing can escape, is so vast that light itself would take days to cross it. Pause for a moment and picture that. Light travels at nearly 300,000 kilometers every second. It circles Earth more than 7 times a single second. Yet even at that astonishing speed, crossing the event horizon of such a colossal black hole would require days. That isn't simply big. It's almost impossible for the human mind to comprehend. But size alone isn't what makes these cosmic giants frightening. Gravity is. Contrary to what many people assume, if our Sunday were magically replaced by a black hole of exactly the same mass, Earth would continue orbiting almost exactly as it does today. We would freeze without sunlight, but we would not suddenly be pulled into the black hole. Gravity depends primarily on mass and distance, and on whether that mass is a star or a black hole. So why is an ultramassive black hole different? Because its mass is beyond anything our solar system has ever encountered. Every object in space exerts gravitational influence. Usually those influences are tiny compared with nearby stars or planets. But a black hole containing tens of billions of solar masses would dominate an enormous region of space. Long before it ever reached Earth, Astronomers would detect subtle changes. The motions of distant stars would begin to shift. The paths of comets in the outer solar system would slowly drift away from their predicted orbits. Sensitive instruments would notice strange distortions in the light arriving from distant galaxies. Instead of traveling in straight lines, their light would curve around the approaching giant, creating spectacular gravitational lensing effects predicted by Albert Einstein over a century ago. Galaxies behind the black hole might appear stretched into glowing arcs, or even duplicated into multiple images. It would look as though the universe itself had become a hall of mirrors. This phenomenon isn't science fiction. Astronomers observe a gravitational lensing throughout the universe today, using it to map invisible dark matter and discover distant galaxies. But if an ultra-massive black hole approached our region of space, these effects would become dramatically stronger. The night sky slowly transform. Constellations that guided humanity for thousands of years would no longer remain fixed. Familiar patterns would begin to warp almost imperceptibly at first. Over years, then decades, the distortions would become impossible to ignore. For future generations, the sky would tell a completely different story. Civilizations throughout history looked upward for navigation, mythology. But now every glance at the heavens would serve as a reminder that something unimaginably powerful was drawing closer. And the most unsettling part? At this stage, Earth itself might still be perfectly safe. The greatest danger would not be immediate destruction. It would be the realization that the universe had already begun changing around us, and that we were witnessing only the first signs of an event unlike anything humanity had ever experienced. Because once a black hole of this scale entered the outer reaches of our cosmic neighborhood, its influence would no longer be limited to bending light. It would begin reshaping the architecture of the solar system itself. The first unmistakable warning would not come from Earth. It would begin far beyond Neptune, in a frozen realm where sunlight is little more than a distant glow. This is the Oort cloud, a vast spherical shell of icy bodies believed to surround our solar system. Stretching perhaps a light year from the sun, it contains trillions of ancient objects left over from the birth of the planets more than 4 billion years ago. Most of them have remained undisturbed for eons, moving so slowly through the darkness that they seem almost frozen in time. But an ultra-massive black hole changes everything. Its gravity would reach into this distant frontier long before it came anywhere near Earth. Not with a violent tug all at once, but with a persistent, invisible pull that gradually rewrites the motions of countless objects. Imagine gently nudging a perfectly balanced stack of dominoes. The first movement, almost impossible to notice. The last one is impossible to ignore. As the black hole's gravitational influence spread through the Oort cloud, millions of icy bodies would begin drifting from their ancient orbits. Some would be flung out of the solar system forever. Others would be sent hurtling inward toward the sun. Suddenly, the inner solar system would face an entirely new threat. Comets. Not one or two spectacular visitors lighting up the night sky every few decades, but potentially thousands arriving over centuries. Some would pass harmlessly through space. Others could cross the paths of planets, including Earth. Scientists already know that even small gravitational disturbances can redirect long-period comets. Passing stars have likely done so throughout the history of our solar system. But compared with one of the largest black holes ever discovered, those stellar encounters would seem almost insignificant. The skies above Earth would become increasingly active. Brilliant comet tails would stretch across the heavens. Some would be visible, even during daylight. Others would grow brighter each night, becoming objects of both beauty and fear. Human civilization has always associated comets with change. Ancient cultures often interpreted them as omens of disaster. While we now understand their scientific nature, seeing dozens, even hundreds, of exceptionally bright comets over a relatively short period would still leave a profound psychological impact. People everywhere would ask the same question: what is causing this? The answer be almost unbelievable. A monster hidden in the darkness between the stars. As astronomers continued gathering data, another mystery would emerge. The planets themselves would begin behaving differently. Not dramatically, At first, Earth would still complete one orbit around the Sun every year. Seasons would continue. Days would still pass. But precision matters in astronomy. Modern observatories can detect tiny deviations in planetary motion, measuring positions with astonishing accuracy. The slightest unexpected shift becomes a clue that something deeper is happening. Mercury's orbit, Mars' trajectory, the distant path of Pluto, every calculation would require new corrections. Every year, those corrections would grow larger. It would resemble hearing a perfectly tuned orchestra slowly drift out of harmony. Each instrument still plays its own part, yet together something feels unmistakably wrong. Gravity, after all, is a universal language. Every object responds to it. Every orbit depends on it. And now, the solar system would be trying to adapt to a new gravitational giant entering the neighborhood. Meanwhile, telescopes across Earth and in orbit would focus intensely on the approaching black hole. Unlike stars, black holes emit no visible light of their own, but they reveal themselves through their surroundings. Gas falling toward the event horizon becomes unimaginably hot, sometimes reaching millions of degrees. It radiates enormous amounts of X-rays and other high-energy light before disappearing forever beyond the point of no return. If this black hole carried a large disk of gas and dust, it could become one of the brightest objects ever observed. Ironically, one of the darkest objects in existence might also become one of the most luminous. Powerful jets of energized particles could erupt from regions near the event horizon, extending thousands or even millions of light-years into space. These jets are among the most energetic phenomena in the known universe. They are not emitted from inside the black hole itself. Instead, they arise from magnetic fields interacting with superheated material spiraling around it at nearly the speed of light. Some galaxies are dominated by these colossal jets. If one happened to point toward Earth, the consequences could be devastating. High-energy radiation has the ability to damage planetary atmospheres, disrupt satellites, and increase radiation levels across space. Fortunately, astronomers believe the orientation of such jets depends on the black hole's environment. There is no reason to assume they would automatically target us. But the possibility alone would become the focus of endless scientific debate. Governments would fund emergency research. Space agencies would launch new observatories. Every major telescope on Earth would monitor the object's behavior 24 hours a day. For the first time in history, humanity would have a single shared mission: understand the approaching giant. Around the world, ordinary people would react in very different ways. Some would refuse to believe the data, convinced that scientists had made a mistake. Others would panic, expecting immediate catastrophe. Religious leaders might interpret the event through spiritual traditions. Philosophers would revisit humanity's place in the cosmos. Artists would create works inspired by the changing heavens. Children would grow up under a sky unlike any their grandparents had ever seen. And somewhere, a young student might decide to become an astrophysicist because they wanted to understand the greatest mystery their generation had ever witnessed. History shows that humanity often advances most rapidly when faced with extraordinary challenges. The space race transformed technology. Global scientific collaborations mapped the human genome. The discovery of gravitational waves confirmed predictions Einstein made a century earlier. Now imagine what could happen if every major scientific institution on Earth united to study a single object rewriting the rules of our cosmic neighborhood. New theories would emerge. Old assumptions would be challenged. Technology would evolve faster than ever before. Yet despite all these advances, one question would continue haunting every scientist. How close? Too close? Because gravity doesn't announce a clear boundary where everything suddenly changes. It's influenced steadily stronger. Eventually, the black hole would reach a distance where subtle orbital adjustments were no longer the greatest concern. The balance that has kept the solar system stable for billions of years would begin to unravel. The giant planets Jupiter, Saturn, Uranus, and Neptune would be the first to feel it. And once the outer guardians of our solar system started moving, nothing closer to the sun could remain untouched. For billions of years, The solar system has performed an extraordinary balancing act. Every planet, every moon, every asteroid follows a path shaped by gravity. These orbits are not random. They are the result of countless gravitational interactions that have settled into a remarkably stable configuration over immense stretches of time. Earth, the Sun, the Moon, Earth. Jupiter acts like a colossal cosmic shield, capturing or deflecting many objects that might otherwise threaten the inner planets. It is delicate dance. And now, a new dancer far more massive than any participant before has stepped onto the stage. As the ultra-massive black hole moves closer, its gravity begins competing directly with the Sun's influence. This doesn't mean planets are instantly ripped away from their orbits. Space is far too vast for such dramatic changes to happen overnight. The process begins with tiny disturbances that grow steadily larger. Imagine spinning perfectly balanced top. Now, we tap it. At first, the movement is barely noticeable. But if you continue applying small forces over time, the top begins to wobble, then drift, until eventually it falls. The same principle applies to planetary orbits. Minute gravitational nudges accumulate, year to year, century after century, until the solar system itself starts losing its balance. The first major signs would likely appear among the outer planets. Neptune, the most distant giant planet, would experience subtle shifts in its orbit. Uranus would follow. Their paths around the Sun would no longer match centuries of precise astronomical predictions. Then Saturn. Then Jupiter. That last name matters more than any other. Jupiter is not simply another planet. It is the heavyweight champion of our solar system. Containing more than twice the mass of every other planet combined, Jupiter's gravity shapes the motion of countless asteroids and comets. Without it, Earth's history might have been very different. Some scientists even believe Jupiter has reduced the number of catastrophic impacts our planet has experienced over billions of years. But what happens when even Jupiter begins to drift? The answer is unsettling. Its gravitational protection starts to weaken. Asteroids that once remained safely trapped in stable regions could become destabilized. Objects in the asteroid belt between Mars and Jupiter might begin wandering onto entirely new trajectories. Most would never come close to Earth.